Hi everyone and welcome back to another lab. In this hands-on lab, we will walk you through the entire process of setting up a Cisco device for SSH access and test it with the management PC from Packet Tracer Lab. SSH or Secure Shell is a powerful protocol that allows us to manage devices remotely while keeping our communication secure. We will start our lab with a brief introduction to SSH protocol and how it works, followed by an overview of the lab topology and objectives. Then we will go over the lab tasks, and then finally I will walk you through the lab solution. By the end of this lab, you will have a solid understanding of the key requirements for configuring SSH access on a Cisco device. You will also learn how to generate RSA keys, which is an essential step in enabling secure remote access, and you will be able to configure and verify a local user database to manage authentication for remote users. Finally, you will be able to test the SSH connectivity to their configured device. So first things first, what is SSH and how does it work? As mentioned earlier, SSH stands for Secure Shell, and it is a secure way for two devices to communicate over an untrusted network. It is commonly used to manage systems remotely and transfer files safely and protect network services. Unlike older methods like Telnet and FTP, which sends information in plain text and can easily be intercepted, SSH, on the other hand, encrypts the data exchange between the devices. This encryption ensures that the information stays private and accurate and comes from a trusted source. So SSH works by establishing a secure and encrypted connection between a client and a server. When a client initiates a connection, it sends a request to the server, typically using port 22. The server responds by providing a public key, which begins the encryption process, and this key is essential for ensuring that the communication between the client and server remains secure and private. A key exchange then takes place using protocols like Diffie-Hellman or RSA. This handshake securely shares encryption keys while preventing interception by unauthorized parties. During this stage, the client also verifies the server's authenticity by comparing its public key with a list of trusted keys stored on the client system. This ensures that the client is connecting to the intended server and not an imposter. Once the connection is secure, the user is authenticated. And there are two primary methods of this. You have password authentication and public key authentication. So password authentication involves the user providing a password, which is encrypted and sent to the server for verification. The public key authentication, on the other hand, uses a pair of keys, a public key stored on the server and a private key kept by the client. The server sends a challenge that can only be answered by the client using its private key. After successful authentication, SSH establishes an encrypted communication channel. This encryption protects all data exchanged during the session, including commands, responses, and file transfers. And finally, SSH is widely adopted because it combines security, flexibility, and ease of use. Okay, so with regards to the lab topology, as you can see on the screen, from a layer 1 perspective, you can see that management PC is connected to switch 1, switch 1 is connected to router 1, and then router 1 is interconnected with router 2 and router 3. And from layer 3 perspective, OSPF has been enabled on router 1, router 2, and router 3, and each router has a unique loopback IP address. So for example, router 1 has a unique IP address of 1.1.1.1, router 2 has an IP address of 2.2.2.2, and router 3 has an IP address of 3.3.3.3. And currently, the management PC should be able to ping each router successfully. And the objectives of this lab is to enable the management PC to be able to remotely access router 1 via SSH. So with regards to the lab tasks, we will begin by verifying connectivity between the management PC and all three routers to ensure the network is functioning as expected. Next, we will attempt an SSH connection to each router from the management PC. At this point, we should find that SSH is unavailable on router 1, but we can connect to router 2 and router 3. Then we're going to go to step number 3, where we will access the CLI of router 1 and configure the domain name. This step is essential for enabling RSA key generation, which is a critical component for SSH functionality. After that, we're going to go to step number 5. We will create a local admin account on router 1. This account will be used for authenticating SSH sessions. And also we are going to set a secret password for privilege mode access. Next, we are going to enable SSH on the VTY lines and restrict access to SSH only. This will prevent insecure protocols like Telnet from being used. Finally, we will test the SSH connection to router 1 from the management PC, and that will confirm if our configuration was successful or not. If the SSH is successful, we can then go ahead and save our configurations, and that will be the end of our lab. So before we proceed to the lab solution, if you would like to test your knowledge on this topic, you will find a post linked in the description below. The post includes lab information and a couple of packet tracer labs, which are provided in a Microsoft document. You can download the document to access both the pre and the post lab versions. Okay, so I'm going to jump into the first task where we need to verify connectivity between the management PC to router 1, router 2, and router 3. And we are going to use each router's loopback IP address. So I'm going to go to management PC stencil, and then from there I'm going to go to desktop and then command prompt. And from here I'm going to say ping 1.1.1.1. And the ping was successful. I'm going to also ping router 2. And finally, I'm going to ping router 3. As you can see that we have reachability and connectivity between the management PC to each of our routers. Next, I'm going to jump into step number 2, where we need to initiate an SSH connection to all routers. However, initiating a connection to router 1 should fail, and the connection to router 2 and router 3 should be successful. So I'm going to say SSH space -L, and then I'm going to say admin, and then I'm going to include the loopback IP address of router 1. I'm going to say 1.1.1.1. And as you can see, the connection to router 1 has been closed, or the connection was refused by the router itself. I'm going to do the same thing, but for router 2. So I'm going to say SSH-L admin 2.2.2.2. And you can see that we have been prompted with a password. And the password here is all capital case IEE. And now you can see that I have logged into router 2. So if I say show IP OSPF neighbor, for example, you can see that I am neighboring with router 1 and router 3. Okay, so what I'm going to do next, I'm going to exit from router 2 and I'm going to up arrow this, and I'm going to try to SSH to router 3. And again, I'm going to use the same credentials. And as you can see, I'm logged into router 3. And again, I'm going to say show IP OSPF neighbor. And you can see that router 3 is a neighbor with router 1 and router 2 using the OSPF protocol. Okay, so what I'm going to do next, I'm going to exit from router 3 and I'm going to jump into router 1 CLI. So I'm going to go back to my topology and I'm going to go to router 1 and I'm going to go to CLI. And from there, I'm going to go to user privilege mode, and then I'm going to go to global config mode. So we need to tackle step number 3, where we need to configure a domain name on router 1. So I'm going to say IP domain -name, and I'm going to say ieverythingeverywhere.com. So this command is vital for enabling SSH on a Cisco device because it is required for generating cryptographic RSA key pairs, which are the backbone of the SSH protocol's secure communication. The IP domain -name command sets the domain name for the device, and this domain name combined with the host name of the device is used to create a fully qualified domain name, or FQDN. So without the domain name, the device cannot generate the RSA keys because the FQDN is a mandatory part of the key generation process. And just to let you know that SSH relies on cryptographic RSA keys to encrypt and secure the data exchanged between the client and the device. The RSA key pairs includes a public and private keys, as discussed earlier, and these keys are used for encrypting and decrypting communication during an SSH session. So what I'm going to do next, I'm going to jump into step 4, where we need to generate an RSA keys with a key length that must be greater than 768 bits. So what I'm going to do, I'm going to say crypto space key generate RSA, and then we're going to say general-keys, and then we're going to say modules. And if we question mark this, you can set any bit, but it has to be greater than 768. So I'm going to say 2048, and then I'm going to hit enter. And as you can see here, it says that the key module size is 2048 bits, and it has been generated with a timestamp. Okay, so let's just do some in-flight checks. So I'm going to say do show IP SSH. And as you can see from the output, that SSH has been enabled. The current version is 1.99. And what I'm going to do next, I'm going to actually jump into the next step where we need to create a local admin account with full administrative privileges. So I'm going to say username and I'm going to type admin and I'm going to set the privilege to 15. And by the way, the privilege 15, that's the highest privilege that you can assign to a user, which means when the user try to SSH to the device, they will go to user privilege mode instantly. And after that, I'm going to use the command secret to encrypt our passwords in the running config. It is more secure than using a password command. And I'm going to set the IEE password or secret. And then I'm going to hit enter. Now I'm going to verify our configuration with this command. I'm going to say do show run pipe include username, and you can see that our secret has been encrypted. Next, I'm going to jump into step 6 where we need to set a secret password for privilege mode. So I'm going to say enable secret, and this time I'm going to use the password Cisco. And again, if I up arrow this multiple times to get to that command and just try to include enable, you can see that the password again has been encrypted. Okay, so at this point, we can go ahead with step number 7, where we need to enable SSH on the VTY lines and restrict access to only SSH. So I'm going to say line VTY 0 all the way to 4. So this command is used to configure settings for virtual terminal lines, which are the logical interfaces that enables remote access to the device. And VTY lines are most commonly used for protocols such as Telnet and SSH. And by the way, the range 0 to 4, that specifies the first 5 VTY lines, which are the default number of lines configured on most Cisco devices. Each VTY line represents an individual session, meaning it can hold up to 5 simultaneous remote connections that can be handled using these lines. So what I'm going to do, I'm going to execute the transport input SSH only. So if I question mark that, you can see that I can hit enter and that will complete the command. I also need to use the login local command. And this command is used to specify that the device should authenticate users based on local credentials stored in its configurations. And then finally, I'm also gonna issue the logging synchronous. And this command is used to manage the display of log messages during user interaction with the CLI. So when this command is enabled, that means if I get a syslog message, that will not interrupt my input and my interactions with the CLI. So I'm going to then hit exit and I'm going to hit end. And then after that, I'm going to just do some in-flight checks. So I'm going to say show run pipe include VTY. And I'm going to actually change that from include to section. And I'm going to say VTY. And here are the configurations that we have pushed under the line VTY 0 all the way to 4. Okay, so at this point, we have completed the majority of our tasks. So I'm going to go to task number 8, where we need to test the SSH connection from our management PC once more. And let's have a look. So I'm going to go back to my topology and I'm going to go to the management PC once more. And here I'm going to just up arrow this multiple times and I'm going to hit enter. And this time we are prompted with a password and I'm going to issue the IEE all capital case password. And now we have entered the router 1 CLI. If I say show IP OSPF neighbor, you can see that we are neighboring with router 2 and router 3. And there is another command that I also want to show you, which is the show users. And as you can see that we are using the line VTY here, where the asterisk is showing on the line. The current user is admin, and you will find other statistics under this command. Okay, so that's it folks for this video. If you found this video helpful, please don't forget to give it a thumbs up, and if you haven't already, please hit that subscribe button and turn notifications so you never miss our future tutorials and tech insights. If you have any questions, comments, feel free to drop a comment below. I read all your comments and I'm here to assist you. Remember, consistency and hands-on practice are key to success, so stay curious, stay inspired, and until next time, peace.